way that servers can share the information about their current state, and also they can share the information about the channel in which they are communicating. Now, when they are sharing the information about their state, or whether they are communicating it through the channel, what can administrator do is the administrator can modify certain predefined values. Okay, so here what is being done, there is a communication between clients, which can either be host or which can either be server, is done. This communication is majorly monitored by various different managers for identifying the state of the network, or for identifying what are the different processes which are running into the network. Okay, so this entire SNMP protocol is a very simple protocol in architecture. But when we are considering the programs which are based upon this SNMP, the structure of such programs is very complex. So we'll move to this structure at a very later stage. As of now, we'll only discuss what are the basic concepts behind SNMP. So when we are talking about SNMP, it's majorly a framework for managing the devices in an internet using the TCP/IP protocol suite. What does it do? It provides a set of fundamental operations for monitoring and maintaining an internet. Okay. Now, when we are talking about what are the different modules in an SNMP, so the basic concept is that your SNMP is majorly a application layer protocol. So it is a protocol that is implemented on the application layer of the networking stack. The protocol was created as a way of gathering the information from very different systems in a consistent manner. Now, there can be multiple ways it can be used in connection with to a diverse array of systems. The method of querying information can change, and the paths to a relevant information are generally standardized in that case. So for that very reason, there are multiple versions of SNMP protocol, and many network hardware devices implement some such forms of SNMP access. Now, the most widely used version is SNMP v1, but the problem is that it is very insecure in many ways. So, its popularity largely is based upon its ubiquity and the long time uses. Unless you have a very strong reason not to use an SNMP version 1 because of its insecurities, we recommend you to use SNMP v3, which provides advanced security features. Now, in general, a network being profiled by SNMP will mainly consist of devices which are SNMP agents and SNMP manager. So what is an SNMP agent is? An agent is a program. I told you in last lecture as well that agent can be part of your system, which normally monitors or which checks on the activities which are happening into your system. So what will you say? That an agent is a program that can gather the information about a piece of hardware, organize it into predefined entries, and recommend to queries which are being governed by the SNMP protocol. Okay. The next thing is your manager. That is an SNMP manager. What does an SNMP manager do? A network, let's say there is a component of this entire SNMP model that queries the agents for the information. So the one who queries the agent would be referred as the SNMP manager. So those systems or those machines which are referred as SNMP manager generally have data about all of the SNMP enabled devices in their network, and can issue the request to gather the information and set certain properties. So if I want to visualize it, I'll say that there is a normal server which can be referred as your SNMP manager, and there are SNMP agents corresponding to the clients. So whenever a server requests for the activities which are being happening at the site of the client, the server will be referred as SNMP manager and the clients will be configured as SNMP agents. Okay, now in case of an SNMP manager, uh, let's see, this is a diagram which shows that this is an SNMP manager. This link is the proper internet, or these are the devices which are present into a proper internet interface, and these are the agents. So this is a manager and these are the clients. Okay, now what benefit happens in a case when you are having SNMP is your protocol is designed at the application level. So the SNMP manager can monitor the devices made by different manufacturers and installed on different physical networks. So it doesn't need to have a standard way so that it can only communicate with X set of devices or Y set of devices which are manufactured by different organizations. Even if there is a difference in the manufacturing unit, still you can use the SNMP model, which is governing all of these organization or devices, and it can exchange the information. Now, this exchange of the information is very essential, and we cannot consider certain case where the manufacturing units are different, because see, I have two of these systems. Both of these systems are manufactured by different companies. So their set of rules, their way of writing log files would differ. Now, if there is a difference in the writing of the log files, there can be, let's say in the first one it has 5 parameters and the other one has 15 parameters. And among those 15 parameters, there are only 4 parameters which are essential for you. So it would not be the case that you will reject that 15 parameters file. What you do is you accept the information which is there from both of these devices, extract whatever is essential for your governance, and then forward it. So that is why it is said that you will not be biased towards any manufacturer or any installations which is there on the different physical networks. So this means that the SNMP frees the management task from both the physical characteristics of the managed devices and the underlying networking technology. Now, it can be used in a heterogeneous internet made of different LANs and WANs, and these are normally connected by the servers and routers which are made by different manufacturers. Okay. Now, the manager can actually be any machine that can send query requests to SNMP agents with the correct credential. Sometimes what happens that this query is implemented as a part of a monitoring suite, while other times this is an administrator using simple utilities to find out quick requests. So almost all of the commands which are defined in the SNMP protocol are designed to be sent by a manager component to, to the agents. So what possibly can be these commands is you can have these are the certain queries which can be sent from one particular manager to the other agents. These normally include get requests, get next request, get bulk request. So the set request is there. You have trap message, you have response for each. So the manager is normally, along with these, it is designed to have trap and the response messages as well. Now, if we talk about the other section, which is referred as SNMP agent, what we see is the SNMP agents do the major amount of work here. What are they responsible for? They are majorly responsible for gathering the information about the local system and storing them in a format that can be queried to the manager. Now, on querying it, they'll have to store it, that is updating a database, which has to be done by this particular agent. So you have a standard information, standard name for that particular database, which is referred as MIB, that is Management Information Base. Okay, what is this MIB? This MIB is a, let's say it's a hierarchical representation of a predefined structure, which normally stores the information that can be queried or which can be set. So set is something which I said that there is a predefined values into the client or the server. Your manager can send in the request to the agents to either update those queries or reset the values depending upon its requirement. So this thing is part of your MIB. Now this entire MIB is available to well-formed SNMP requests, which are originating from a particular host which has been authenticated with the credit with the correct credentials. Now, what does this mean is you have a predefined architecture of how the information actually flows between different objects. So let's say this is a particular architecture. Fine, this is actually not an MIB, but I'm just pointing it out that this is the entire hierarchy in which your files will be updated. Now, whenever we are talking about any updation, we are generally considering that updation would be done at the end of the agents. Okay. Now, when an agent is updating a particular database, it would obviously be checked that the updation from the server which is being requested and is being done by a particular agent is done on the basis of the authentication. If the authentication credentials are valid, so these credentials will majorly be of a SNMP manager. Okay, so when you are updating it, once on authentication, then only the values will be updated. Now, the SNMP agent is actually a machine. So this entire machine configures which managers should have access to its information. It can also act as an intermediary client to report the information on the devices. It can connect to that. Uh, it can also say that the SNMP is not configured for a particular traffic. So this says that there needs to be a lot of flexibility in your components which are present online, and it should also have the functionality that the SNMP needs to be accessible every time. So if let's say there is a case where you have your SNMP manager and you have the SNMP agents. However, in one of the cases over here, let's say the SNMP agent corresponding to the router is not functioning. Okay. So in that case, even if the manager sends in the request for, let's say, to get request, or it says get next request, it would not be satisfied until and unless the SNMP module has been completely configured on this particular agent. So what normally is being done by the SNMP agents is that these agents respond to most of the commands which are defined by the protocol. So what were the response? The response will be corresponding to these all operations, which is get request, get next request, get bulk request, set request. So along with the one which was said in the SNMP manager, that the manager sends in the trap messages, or the manager sends in the response messages. So the major trap message is sent by the agent and a response is generated by the manager. So both these agents and the managers are configured to communicate the status of the system or the status of the processes which are running onto the particular host. Okay. Any doubt till now? Should I repeat something? Any doubt? Okay. My speed is okay. Am I moving very fast? Okay. So I told you about the basic idea of SNMP. The basic idea is that the manager checks an agent by requesting the information which reflects the behavior of a particular agent. Next thing is the manager forces an agent to perform a task by resetting the values in the agent's databases. And the third thing is an agent contributes to the management process by warning the manager of any unusual situation. Okay, now these are the three basic ideas on which an SNMP is based. We considered a message which is referred as trap. So when is this trap issued, who issues the trap, and who responds to the trap is who issues it? Your agent issues the trap. Response is done by the SNMP manager. Okay. Now the trap is issued in what cases? Trap is issued in that case when there is some unusual activity which is encountered on the system. So that particular system is majorly the host system or the one which is running the agent. Okay. So along with these information, the other things which need to be focused upon is what is actually your management information base. So in a brief, I told you that the MIB is a set of database that follows a standard that the manager and agents are adhering to, and it is basically a hierarchical structure. In many particular areas, this entire hierarchical structure is globalized. Okay, so you'll have a standard global MIB, which is to be followed by every organization who manufactures something. Now, even though there is a standard architecture, the architecture needs to be flexible also to allow the vendor specific additions. So let's say there are some other components as well which the particular vendor has added, or any other processes which are added onto the architecture or into the hardware system. So such informations can be added into the MIB as well. So it is basically a top-down hierarchy. So here each branch that let's say here. So here each branch that moves out is labeled with both an identifying number. You can see that there is a number like 3611 over here. So each branch is labeled with an identifying number. So this number is majorly always starting with 1, and an identifying string. So the string over here is org, ISO, join. Okay, and an identifying string. that are unique for that particular level of the hierarchy. So you can see that you have a 1 as well and 1 as well. So, but the level of both of these hierarchies is different. Okay. Now you can use these strings and numbers interchangeably. So whatever you want, that can completely vary depending upon what is your standard way of accepting it. Now, in order to refer to a particular node of the tree, so let's say if you want to refer to any specific node of the tree, what you should do is you must trace the path from that unnamed root of the tree to the node in question. So this entire lineage of its parent IDs, let's say the numbers or strings, are connected together, starting with the most general to form an address. Now each conjunction in the hierarchy is represented by a particular dot. So I'll tell you an example over here. It's not here. So what I can point out from here itself is, okay, so let's say we need to move on to this particular route. What would be done? Here it would be referred as 1.1.6.3.1. So depending upon this entire path and the numbers associated to the particular node, you can reach to the other nodes. So which says that the each node in a particular hierarchy is represented by a dot, so that the address ends up being a series of IDs or numbers which are separated by a particular dot. Now this entire address or uh, the entire information is known as object identifier or OID. So what normally is being done, if you want to identify a particular variable or a particular linkage, what you will do is you will move on to the entire hierarchy from whatever, say you can be generally refer it as top to down hierarchy structure. So depending upon the lower hierarchy, we can reach to the actual root node. Now, what do the hardware vendors do is the hardware vendors embed the SNMP agents in their devices sometimes, which have custom branches and their own fields and the data points. However, there are standard MIB branches that are well defined and can be used by any device. The standard branches which we are discussing will be under the same parent branch structure. So what does that mean is that the ISO, ORG and DoD and internet, these are certain standard branches. So these will always be present below the root node and will always be connected in this way. However, if there are any other alterations, they would be mm, changed according to the one according to the vendor. So you can have either a ID path or you can have a string path. Fine. Now the Cisco majorly focuses upon a tool named as SNMP Object Navigator, which is used to drill down into the hierarchy and to find information you need. Similarly, you have a company named as Solar Binds. This also provides similar information of the object IDs. So what is it used for basically? Or what is this entire MIB is considered for? Is that if you want to query any device for the information, what has to be done? You will follow the path which is provided in the form of, let's say, 1.3.6.1.2.1. So if you are provided the path, you can browse the entire tree interfaces to learn what kind of the information is available to query and what values can be set for those particular variables. Okay. Now moving ahead, similarly, you have this as a subtree. So this is also an MIB tree where you are having your MIB2, which is having multiple values. So here see, there is an MIB2 which has a sequence number 1 associated to it. With that particular MIB, there are other values of IPs, ICMP, TCP, UDP, transmission, SNMP. So whatever packets are there or whatever information is associated to the particular packets, it can be found into this. And if you want to set the values or retrieve the values and communicate it to the SNMP manager, you can follow the entire path. Okay. Um, Next, the we'll move on to the operations first. You can refer them as protocol commands as well. So one of the reasons that the SNMP has been given such heavy priority is because of the simplicity of the commands which are available with the SNMP. Now, there are very fewer operations to implement in SNMP, and it's very easier to remember. But they are flexible enough to address the utility, which are the basic requirements of the protocol. So these are the operations, or you can say that these are the following PDUs. PDUs means protocol data units, which describe the exact messaging types which are allowed by the protocol. So the first one is get. What is this get? It is a get message which is sent by the manager to an agent to request the value of a specific object ID. So if I want to find out a value of a particular MIB or a particular ISO, I would use this get command. Now, what is the response for this, or what is the packet which is being sent in reply for this? The request is generally answered with a response message that is sent back to the manager with that particular required data. Okay. Next is similarly get next. The get next message allows a manager to request the next sequential object in the MIB. So here the next sequential object, let's say the requested one was therefore ISO. The next sequential one would be joint. Okay. Uh, so this is the when we are talking about get next, we normally say that you can traverse the structure of MIB without worrying about what OIDs it has to query. So I send in a message which is get first. Next, if I don't know, I want which particular variables information to be extracted. What would be done? I'll again send get next. So whichever object or whichever variable is there next to it, I'll get the response directly. The other one is set, so which says that it can directly set a particular value, or it can change the value held by a variable on the agent. Now this can be used to control configuration information, or otherwise you can modify the state of the remote host. This is the only write operation which is defined by the protocol. So you do not have any authorization to modify the values. So this is the only operation which can modify the existing host set status. So there needs to be certain credentials or authorization rights. Only then this particular operation would be advised. The above one was get bulk. So what does get bulk do is it is also sent by the manager to the agent. Here the manager requests the functions as if there are multiple get next requests which are made by the manager. So the reply to the manager will normally contain as many variables information or as much data as possible, but within a constraint which is set by that particular request. So when we are receiving the get bulk message, the reply which is done by the agent would be in such a case that how much is the information allowed in a particular packet. Beyond that, the information will be scraped. Now, response and get response is similar to the per response message. The other one is trap. So we said that trap is normally sent by the agent to a manager. The difference between the get and the other messages and trap is that the trap is basically an asynchronous message. So you can say that it's an asynchronous notification. Now, when we are saying that it is an asynchronous notifications, in that case, the manager is not ready to receive the request every time. So they are sent in an unsolicited way by the manager. They are mainly used by the agents to inform the manager of events that are happening on their managed devices. Okay. The other messages are, we'll move on to inform. So inform is majorly to confirm the receipt of a trap that would be sent by the manager to the agent. If the agent does not receive this message, what would agent do? It would send those packets once again. Which packets? It would again send the previous trap message which was being sent from the agent to the manager. Until and unless an inform packet is received at the agent's end. Okay. The next one is report. What does report do? The report is also a PDU which is majorly designed to report what are the errors. So from where will it be created? Will it be created from the client side, which is the SNMP manager, or will it be created from the SNMP agent side? Normally, the report is sent from the particular client. Here the client is SNMP manager and is being sent to a different manager. So whether there is any error into the system, this error initially has been communicated via trap to the manager. The manager concluded that it's an error and a proper report would be communicated to the other managers into the system. Okay. Any doubts till now?
No, ma'am.
Ma'am, could you repeat inform once again?
Inform. So inform is basically an acknowledge message. So what does informs would say that once a trap has been received at the server side, an inform would be sent to the agent by the manager to inform that I have received the trap message. If the agent doesn't receive the inform message, your agent would again send in the trap message to the manager. Okay, I hope it is clear now.
Okay, ma'am.
So let's see, there is a trap which is being sent here. So here it's a SNMP transport where the medium is a UDP. So normal send and response when it happens, this is your SNMP manager This is a proper internet, uh, and this is a particular agent. So here it is your client, this is your server. Your server has the agent within it. Okay. So now what does the manager do? The manager sends in a request message to the port which is there on the agent. And when the request message is being sent, it is being sent from 1961. Fine. At the agent site, your agent receives the message at the UDP port 161. Okay, since we are saying that it's a UDP transport. Okay, now when the response will be generated, your response will be generated from the agent, and the response would be sent from this port 161 only, and it will be received at 1961. Clear? This is what? It's a synchronous exchange. Receiving जिस पोर्ट पे हुआ उसी पोर्ट से हमने सेंड किया because that was a UDP port. Next is again a UDP port or a UDP transport, but here what is happening? You are seeing a asynchronous transmission. पुराना वाला जो था, this one was normal communication, normal get request, get response. However, here we are talking about sending the message from the agent to the manager, but the message which is being sent is a trap event. Okay, so this particular trap event is originated from the agent. It is being generated, obviously, when it is being sent from the agent, it would be sent using that particular protocol port only, which is 161, but it would be received at port number 162. This is the only difference in case of a synchronous data transmission or in case of a asynchronous message reception. Okay, now let's say this is the case for a get and get response. So here you have client, you have your server. Your client sends in the get request for the router's system name. So your router is a particular agent, sorry, it's a particular host in which your agent resides. Your manager wants to find out the status of the router. So what can be done is your manager can either send in the information of get request along with the ID of the router or the entire path. Okay, what would manager do is it would respond to this get request by get response. The response PDU contains router's system name, which is Cisco. So we already know where is this router system name present. We had this. It is present in this entire object naming, which is represented as MIB. Okay. Next is get next. So with get next, what can be done is you can retrieve a group of calls. So if a group of call is done with the root ID given, root node given, what would be done? We said that जितने जितने objects आएंगे और जितनी values आती जाएंगी, we can receive the values depending upon the hierarchy. So root from root node, it found out, it went to the other node, coming back to the root node once again. The ISO would be visited, then ORG, then doc, then internet. The entire branch would be first visited. Coming back again, it would visit joint, and then it would. So the get next would receive the information of all of these objects and send it to the what's it SNMP manager. Okay. Similarly, you have get bulk. It receives a section of a table. So, as I have already told you, It would reply until the packet size is limit up to a particular limit. So set is also setting a particular value. For this, you need to have the privileges. Trap we already discussed. Now coming to the final thing, which is saying about SNMP V3. So what are the major goals of having an SNMP V3? We said that there were certain insecurities, or there were certain security issues in case of SNMP version 3. Those in SNMP version 1. So those security issues were being addressed in V3, where we had the important triad, which is referred as CIA, that is confidentiality, integrity, and authentication. So SNMP v3 or any security module, whatever exists into the system, is based upon a CIA triad. If it obeys CIA triad, then we say that it is bound to certain security rules. What is it here? The first function is there in case of an SNMP v3 is that it checks the message integrity. How do you check the message integrity? It is just to verify that each received message has not been modified during its transmission. How do we check integrity? We check integrity by comparing the messages. If there is any modification, then the comparison will not give you a value 0. If it doesn't give you a value 0, this says that the message has been compromised. The other factor is confidentiality, or come to the user authentication. User authentication, we already discussed it in last class. It is normally to identify the user and then verify its credentials. So here it says that to verify the identity of the user on whose behalf a received message claims to have been generated. Okay. The last is message confidentiality. What does confidentiality confer to? It assures that the contents of each received message are encrypted or protected, and only the ones with the proper privileges or proper credentials will be allowed to access the message. The final thing which is there is message timestamp, which is normally included in order to identify whether the message which has been received is a valid message or not. So validity can only be identified on the basis of timestamp. So if the message seems to be outdated, in that case, you'll have to drop the message or drop the particular packet so that the violation of the rules doesn't happen. Okay, so the entire SNMP v3 is based upon the security module. So now when we are talking about the security module, there would be multiple cases which says that for integrity, you'll have to use this particular algorithm. For authentication, you'll have to use this particular algorithm. For encrypting the messages and to find out whether the message obeys confidentiality or not, you'll have to use encryption algorithm. So there can be multiple encryption algorithms used. However, the major algorithm which is used in case of SNMP v3 to obey message confidentiality is DES. Okay. I hope you guys are aware of what is DES, or should I explain it sometime? I I hope I do not need to explain DES. Is there anyone who has not gone through DES? Okay, so when I discuss this entire architecture, I'll initially tell you some information about DES. Then we'll go ahead with V3. Okay, so today we'll end the class here itself. It's been a lot. If I start SNMP V3, it will not be possible in this lecture. So, any doubt for today's class?
Ma'am,
Yes,
ma'am, I have a doubt from previous class.
previous class. Okay.
Ma'am, actually, the assignment that you have given, the relation between performance management and fault management, what is
Yes.
the correct answer of it?
The correct answer is it depends upon the situation. The third option which I told you.
Okay.
Ma'am, so could you give an example for like both the scenarios?
Okay. So in some of the assignments, some students spoke about that performance is directly related to fault and performance is indirectly related to faults. Okay. So we said that if a fault occurs, it would decrease the performance. Clear? ये
Yes,
तो
ma'am.
clear है सबको कि अगर fault हुआ तो obviously performance decrease होगा. ठीक है. Let's say the fault occurred into a system which is not affecting the performance of the system. Is this case acceptable? That is a case which is acceptable. So I can say that the entire fault management system will not just focus upon a particular fault, it would also focus upon how to improve the performance of the system. So there can be a fault, but the performance doesn't get altered. Okay. So for your case, the first one is also correct, the second one is also correct. Okay. Now, in case of management, we had certain functions. What were those? कौन-कौन से?
Um,
Reactive and proactive.
हाँ सर बस 5 मिनट. In case of fault management, we were normally talking about traffic. We were talking about the testing. We had device configurations. We prioritize different faults. So when we are talking about any fault management system, we normally say that we are concerned upon SNMP polls. We are concerned upon the statistics into the system. Okay. So depending upon the situation, your outcome or the faults would affect. Okay. Had you considered the fault in advance itself and isolated it, in that case, it would not have affected the performance of the system. So we had the major motive in case of fault management, which was the prevention is done, detection is done, and the isolation of the abnormal behavior is done. Okay. So fault management not just talks about the fault would occur, it also talks about that you have to develop or have certain mechanism through which the entire malfunctioning can be prevented. Am I clear? So this says that the fault management can be either directly or indirectly proportional to the performance management. I am not talking about only performance as a parameter or fault as a parameter. I am talking about fault management and performance management system. So this includes all of these factors which are there. Clear?
Yes, ma'am.
Okay. So we'll start with this in next class again, we'll go with SNMP week 3. Okay? I'll send you the slides.
Okay.
Okay.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.